first things first, looking at this, f of x is minus x plus 4 and x minus 3 and x plus 2. What is the degree going to be on this guy? 3. We have 1, 2, 3 x's being multiplied together. So this is a degree 3, which means we know this is going to be odd. There we go, my pen's being a jerk. Is our leading coefficient going to be positive or negative? Negative. We see this minus sign right out in front here. So that tells me I know by end behavior, I know my right arrow is going to point which way? Down. My right arrow is always going to match its leading coefficient, so my right arrow is going to point down. That is the chonkiest of arrows. Holy cow, we're going to go that way. And since we have an odd degreed function, I know my other arrow is going to point up because odds go in opposite directions. So I know that much. Where are we going to have zeros or roots or intercepts on this guy? Yeah, it's when we set each of these factors, these guys, equal to 0. So for this one, for the x plus 4, what's our root going to be? Yep, because we set our, I'm just going to write it up here, our x plus 4 equal to 0. If I'm talking and writing at the same time, sometimes I skip whole pieces. And then we solve it for our x, so we'd have x equals negative 4. Means I know that's one of my roots. 1, 2, 3, 4, right there. What's our root for the x minus 3 piece? X equals positive 3. 1, 2, 3. And our x plus 2, negative 2. So right here. From that, we can get our little sketchy sketch. We're going to start at one arrow, go to the other, no crisscrossing, no loop-de-loops. I'm going to go down through the green one, up through my yellow one, down through the blue one, and hit the arrow. So it's going to look something like this. I got it here. Okay, questions on this one? Okay, so this bottom one is looking at what we talked about on Friday. So saying this function down here, this f of x minus 3x to the 5th plus 4x squared minus 2x minus 5 has one real root. So we're asked to figure out how many imaginary roots it has. We are told that it has one real root. The real roots plus the imaginary roots are going to add up to be what? How many roots in total is this going to have? This guy in total is going to have 5 roots. How do we know it's 5? The highest exponent is 5, our degree. So our real roots plus our imaginary roots need to equal our degree. So if this has one real root, how many imaginary roots is it going to have? 4. Because 1 plus 4 gives me 5. So our answer would be 4. The real roots plus the imaginary roots needs to equal our degree. Okay. Questions on this one? All right. I want to do another one of our find all possible factors kind of guys, and then we'll talk through kind of the vibe of this week. So I'm going to give you a factor. We know x minus 2 is a factor of this, and we're asked to find all the others. So here is our first problem for today.
Can you write it on the board?
Oh, no, this is not bell work. And, oh, I guess I didn't give us an SAT practice problem. We're just hopping straight into it. I don't know how I wound up with one that didn't have it. That got put in by somebody else. There you go. I can't make sense of them. All right. So, what do we do? Ugh. What do we need to do here? What is our first step going to be? Bless you. Yeah, we can do that and set up our synthetic division. Is there a greatest common factor?
I don't know. I can't check that.
I can grab the calculators. Understood. I don't remember which cabinet it was. That was kind of shoving some big cabinets. There we go. I found it. Oh, and some cables. Fun times. I'll grab you one. We're not pressed for time today. Be good.
I don't usually do calculators in the briefing.
So that would be a null. Right.
You're right. They do not have a greatest common factor. Partly easy way to see that is that 8's even and only divisible by 2. 27 is odd and only ever divisible by 3's. So 8 and 27 do not have any factors other than 1 in common. So what do we do next if there's not a GCF? Synthetic division. It's a fine place to start. So I'm going to put my little structure here. What do we put in this? Walk me through it. So we're going to have our 8, then the minus 16, minus 27, 54. What else?
What number in the box you want? What is
It's not going to be a 1.
2?
How do we know that?
Oh, because it's the opposite.
Yeah. So this is where we find our root for this guy. Our x minus 2 equals 0. So this is going to give us a root at positive 2. So we have a positive 2 in the box. All right, what do we do next? Drop the 8. Goes all the way to the bottom. What goes here? Say it again. It would be 8 times 2. And then we're going to add. Negative 16 plus 16 gives me 0.
Wait,
What's up?
there's no x squared.
Oh, no. Oh, no. Did we miss a thing? I was going to use it to show us a lesson. Oh, snap. So if we keep going with this, we multiply our 0 times 2, we get 0. And we add to get a minus 27. Negative 27 times 2 gives us what?
Negative 3.
Negative 54. Or did it work anyway?
It would work anyway, yeah.
Oh, okay. I lost the lesson on here because I wound up with a different piece that I wanted. But that's okay. It still works. But we are actually getting a wrong answer here because when we do this and we get our 0 over here, what degree is this piece going to have? X cubed. But when I give out all my pieces here, and this guy gets my x squared, and then this guy gets my x, this should be my just number, and I don't have a spot for the remainder. I'm missing a piece. It's always supposed to count down. So yes, it came out as a 0, but I don't have enough pieces here. I'm missing a coefficient. Most times when that happens, this remainder would still be a number. So we have the right values, but we're missing a piece because I don't have the right number of spaces. And Abigail noticed that one about halfway through is that we had a power of 4, a power of 3, and then we skipped the 2's and went to a 1. So we should have in the middle of our synthetic division here, I'm going to go back a few steps. In here is where we hit our problem. Because we should have had from our x squareds, we should have had a 0 in here. That will get us to line up because we need to include the fact that we have our 0x squareds in our synthetic division. We have to have that space there. I'm going to give us just a smidge more space by moving these guys over just a touch. So having the values in there for every single piece makes it different. Otherwise, we don't have enough coefficients. We're missing a space on the bottom. So it's not going to honestly change much of our values because we still have our 0 times 2 giving us 0, and we add those together, we still get a 0. We're still going to wind up with a 0 under the 27, which gives us a minus 27. And we again get our negative 54, giving us our 0 on the bottom. But now we have the right number of coefficients because this guy should be my x squared. Nope, cubed. I'm good at things. This guy should be my x squared. This guy should be my x's. This is just a number, and this is my remainder. We need to have all those pieces. I know it doesn't feel like the 0 makes that much of a difference because those numbers were right, but it does because this 27 is not with an x. This 27 is just a number. So our leftover bit, when we're done, we have an 8 that's got an x cubed with it and a minus 27. That's our number. Okay, so that's really important that we have that. Otherwise, we would have had 8x cubed and 27x, and we would have been missing pieces. So it's really, really important that we don't skip that 0, even though it doesn't seem important. It is. Is there anything else I can do to find more factors? Because we were asked to find all factors. And you know where all of our factors are not? They're not on our phones. 1, 2, 3, 4, 5, 6 of us. TikTok does not have our factors. Instagram does not have our factors. We have a test coming up on Friday. Now you're paying attention. Is there anything else we can do to find more factors on this thing? I've got my 8x cubed minus 27. Yeah. Say it again. This one's not going to be super boxable. I'm just going to write it up at the top so it's not quite so at the very bottom. 8x cubed minus 27. Looking at this guy. We see a cube here, so we should be like super cautious about it. Yeah, this is using one of our special patterns, that sum or difference of cubes. Bless you. So we are going to look at these things and figure out what cube gives me 8x cubed. What cube does give me 8x cubed? 2x times 2x times 2x gives me 8x cubed. That would mean the same thing. What cubed gives me 27? Yeah. 3 cubed is 27. So this is a difference of cubes, and this can use that special pattern, which we did give you guys on the homework, and we have there, or I don't have it up right now, but we do have. This is one of those special patterns where if we have our, I'll just write it out here, a cubed minus b cubed, we get, ooh, my screen to jump, that a with the same sign, b, then we have our a squared opposite sign, ab, always plus b squared, like this. Special pattern, we'll give it to you on the test. So what we're doing is we're filling in the blanks. My a piece, the thing that's cubed in the front is this 2x. The thing that's cubed in the back to give us that b piece, that's going to be the 3. So every place we have an a, we're replacing with a 2x, and every place we have a b, we're replacing with the 3. So to put this in our factored form, we're going to wind up with our factors like this, with my 2x minus the 3. Then we're going to have our 2x as a chunk that's supposed to get squared, plus the 2x times 3. And then we're going to add that 3 squared. So we're following the pattern. It still needs us to have those letters in there. I've had a lot of people get confused in the fact that this doesn't have any x's in it, so this doesn't have any x's in it. It doesn't matter what's being cubed. It's not just saying the numbers. It's just a pattern. So we got to make sure we include those letters, because our final factored form for this difference of cubes is our 2x minus 3 and our 2x as a group squared, so 4x squared. 2x times 3 gives us 6x. 3 squared gives us 9. So this is the factored form of the difference of cubes. The factored form of our quartic needs to include the original guy we divided out to, that x minus 2. So this is the factored form, the all possible factors of that polynomial. Because the bottom, the quadratic, is not further factorable, because it's a sum of cubes. So, yes, dear.
So you can put the x minus 2 in the factor.
It doesn't have to be at the beginning. It can go at the end. But if we want the factored form of the whole thing, or all of our factors, put them all together. Okay. Questions on this one? I just wanted to do another one like that. Okay. Because what we have this week is we actually do not have more notes that we need to do. Because originally the test was scheduled for Wednesday, but since Wednesday is when we're having a convocation, I don't want to give us the test in a 30-minute period, which is why we push it back to Friday, because Thursday's an e-learning day. So we have today and tomorrow to review together. Thursday is going to be e-learning, and Friday's going to be our test. So what I have for you guys is I have the chapter review, which I'm going to pass out, and you guys are going to get to work on it all day today. Tomorrow we'll go through any questions excuse me. Tomorrow we can work through any questions you guys want to together. And then Wednesday we have a really short, gamified quiz review that we can do on quizzes, and I will get the treasure box out for it. It's pretty short. And Thursday is e-learning. You'll be at home, and if you guys have any questions, you can ask me. But that's kind of the plan for the week. Pretty chill. Not tons to do together. But so if you guys have any that we want to work through together, we can do that tomorrow. We can do that on Wednesday, whatever we need to do. And and I will get the answer made for it. I do not have it made for this thing. Here it is. Remember, we always give you way more breadcrumbs than there are on a test. So do not forget about the thickness of the jacket. Okay, so we're gonna stop. Let me know if you guys have questions. If you got homework still that you need to catch up on, now's a great time to do so. So yeah, kind of chill. Yeah. Save you? Oh, the review. I did miss you. Review, and then ridge pass. Here we go. I gotta find my passes. I found them. Here we go. Wrong information.